Alright, now we have unit 3. So 41 says f of x equals g of 3x squared. So this is obviously going to be chain rule because we have a function inside of another function. So when I'm looking at taking the derivative, remember we take the derivative of the outside first, so g prime. The inside stays the same, times 3x squared, times the derivative of the inside, which is 6x. And notice this is not a composite function. There is no function inside of another function, so we're done. Meaning our answer here is going to be f prime of x equals 6x g prime of 3x squared, which looks like it matches C. All right, next, what is the slope of the tangent line for the graph? G of x equals 3 sine x at x equals pi. So if we look at g of x, we know slope means we need the derivative. So g prime of x, derivative of the outside, so our outside function here is sine, meaning the derivative of it is cosine. My bad. And then the derivative of the inside is just going to be 3. So we really have the derivative at pi is going to equal cosine of 3 pi times 3. Now if you think of 3 pi, think about the unit circle. Here we have 0. Halfway around is pi. Then around here is 2 pi, which would make 3 pi in the same spot as pi, which would make cosine of 3 pi equal -1 times 3. So our slope of a tangent line here is going to be a, -3. All right, here we have more like the table. So if we have f of x equals g of h of x, we're going to have to use chain rule here because we have function inside of another function. So g prime, so derivative of the outside, leave the inside alone, times the derivative of the inside. And then I just plug in 2, so f prime of 2 equals g prime h of 2 times h prime of 2. So based on my table, h of 2 is going to equal 3. H prime of 2 is going to be -1. And then the last thing I need is g prime of 3. So g prime of 3 is going to be -4 times -1, which makes our answer +4. Okay, the instantaneous rate of change, once again, that's the derivative. So I have h of x equals f of x cubed. So my outside function is the cubed here. So h prime of x is going to equal 3 times f of x squared times f prime of x. We want this at 2, so h prime of 2, 3 times f of 2 squared times f prime of 2. So now we just have to figure this out. Remember, f of 2, since this is the graph of f, we're just going to look at the y value. So my y value here is 1. And then f prime of 2 is going to be the slope here. So the slope through this point is up 1 over 2. So 1/2, which makes h prime of 2 equal to 3/2, or C. Now this is just a basic chain rule problem. So if we look at this, we have 4x squared minus 3 to the power of 5. So to take the derivative, we start at the outside function, which is that power of 5. So this becomes 5 times 4x squared minus 3 to the power of 4. Then we just multiply by the derivative. So the derivative of the inside is 8x. And then since that doesn't match any of our answer choices, we are going to have to simplify this a little bit. And it will become 8 times 5 is 40x times 4x squared minus 3 to the 4th, which makes my answer D. Okay, this one we have equation of a tangent line. So the first thing I need to find is my actual y value. So y equals negative e, and then we know our x value is 1, so I can replace that. So really, my y value here is just going to be negative e to the 3rd. Then my derivative, so y prime, it's going to be negative e to the 3x, because that's our outside function, times the derivative of the inside here is the derivative of our exponent, so times 3. So my slope is going to be negative 3e to the 3x. So then my equation of a tangent line, y minus negative e to the 3rd equals negative 3e to the 3x times x minus 1. And obviously this will become a plus. So y plus e to the 3 equals negative 3e to the 3rd I forgot to plug in a 1. My bad. But since x equals 1, that just becomes a 3. X minus 1. So the answer has to be D. Okay, 47 is one that you need to rewrite. So our function here, remember we want to rewrite this as cosine 3x, and then put the squared on the absolute outside. So chain rule, we're going to start with that 2. Inside will stay the same. Then I multiply it by the derivative of the inside. So derivative of cosine is sine. But we still have a function inside of another function. So now I need to multiply this by the derivative of 3x, which is just 3. So I really get my derivative when I simplify this a little bit. It's going to be 6 cosine of 3x sine of 3x. And really this should be a negative, because I forgot the derivative of cosine is negative sine. So then our answer is negative 6 cosine 3x sine 3x, which should be A. Make sure you don't forget that negative, or else you would have picked B. Okay, 48, we have natural log of g of x. So it's a function inside of another function, meaning I need chain rule. Derivative of my outside function is natural log, so we know it's going to be 1 over x, or in this case, 1 over g of x, times the derivative of the inside function, so times g of x. So that's none of my answer choices, but I can simplify this to make it g prime of x over g of x if we just multiply those two. So our answer here is going to be C. Okay, in this one we have x's and y's combined. That's how you know you're going to need implicit. So we're going to do implicit, meaning anytime we take the derivative of y, we're going to put dy dx next to it. So to start off, my derivative of square root of x is 1/2 x to the negative 1/2 plus 2y dy dx equals, then I'm going to have a product rule. So first times the derivative of the second, which is just 1 dy dx, plus derivative of the first times the second. And then the derivative of 2 is just 0. So next I want to get all of my dy dx's to one side, everything else to the other side. So I have 2y dy dx minus x dy dx equals y minus, I'm going to change that to 1/2 root x. Then I'm going to factor out dy dx. And then divide. So I know dy dx is going to equal y minus 1/2 root x over 2y minus x. But that's not what they wanted. They wanted us to find this at the point 4, 0. So now I have to plug in all the x's are 4's, all the y's are 0. So y is 0 minus 2/2 root 4 over 2 times 0 minus 4. So when I simplify this, the top's going to become 2/2 times 2. So that's just going to be negative 1/2 divided by negative 4. And this is really going to be the same thing as negative 1/2 times negative 1/4. Hold on, where'd this 2 come from? I just wrote a random 2. Sorry, y'all. That should be a 1, which would make this negative 1/4 instead. My bad. So then this is actually negative 1/4 times negative 1/4, which equals 1/16. So be careful, don't replace things that don't need to be replaced. And you should have that as your answer. Okay, 50, we have cosine of y equals x, and we want dy dx. This is another implicit because you have x's and y's mixed together. So the derivative of cosine y is negative sine y dy dx. Derivative of x is just going to be 1. And then I'll divide by negative sine y. So dy dx equals 1/negative sine y. That's not an answer, obviously, but we know 1/sine equals cosecant, so it's just going to be negative cosecant of y as our answer. So C. Okay, 51, another implicit because there's x's and y's mixed, and we want it at the point 2, 1. So here we're going to have derivative of 3x is 3 minus x dy dx minus 1y equals 2y dy dx. The derivative of 3 is 0. Okay, so now I need to get my dy dx's to one side, everything else to the other. So this is going to end up being 3 minus 1y equals, I'm going to factor it out at the same time, 2y plus x. Then I divide, so 3 minus 1y over 2y plus x equals dy dx. And then I need to plug in the points, so all my x's will become 2's, my y's will become 1's. So 3 minus 1 times 1 over 2 times 1 plus 2. So you should get 2 over 4, which equals 1/2, or D. All right, next one. We have an x over y equals x minus y, so it's still going to be implicit. But for this first part, I need quotient rule. So it's going to be low d high, so the derivative of the top is just 1, minus high d low, which is dy dx, all over the square of what's below, which is y squared, equals derivative of x is 1, derivative of y is dy dx. Now, I don't like working with fractions, so let's just multiply everything by y squared. So I'm left with y minus x dy dx equals y squared minus y squared dy dx. Getting all dy dx's to one side, I have y squared. Again, going to factor them out at the same time. Minus x equals y squared minus y. And then divide y squared minus y divided by y squared minus x. So that looks like the answer should be B. Okay, so if two functions are inverse functions, what that tells us is that f of g of x equals x. So it says g is the inverse of f. That's what this means right here. So if they ever tell you that, you have to set up a composite function and it should be equal to x. So if we want g prime, what we're going to have to do is basically take the derivative of this. These type of problems, you should just always follow this same method. So it's really going to be f prime of g of x times g prime of x equals derivative of x is going to be 1. So we need a chain rule there. And our whole point of doing this is we want g prime of 3, so we've created a g prime. Before, we didn't even have any way to get g prime. So now we are looking for g prime of 3. Let's plug everything in. So f prime of g of 3 times g prime of 3 equals 1. So our whole goal is to get that g prime of 3 by itself. So I'm really just going to divide by f prime of g of 3. So that gives me g prime of 3 equals 1 over f prime g of 3. Last thing I'm going to do is just figure out what is that equal to. So g prime of 3 equals 1 over f prime. They tell us g of 3 is 4. And I know f prime of 4 equals -5, so -1/5, which makes my answer A. you've never seen one like that before, but anytime we're talking g is the inverse of f or something like that, you're always going to write this function right here. And that comes from pre-cal algebra 2. So this one's very similar. They just give us the equation instead of making us find it ourselves. So we're looking for g prime again. So I have f of g of x equals x. Just find the derivative. So that uses chain rule. And now we just plug in the value we need. So f prime g of 3, g prime of 3 equals 1. We divide because we want that g prime of 3 by itself. And then in this part, we have to use something else that we know. So we know that these two are inverse functions. Notice how they don't tell us what g of 3 equals. So they tell us f of 1 equals 3 because they're inverse functions. Based on this right here, it tells us that that means they're inverses. G of 3 has to equal 1 because they're opposites. So really, g prime of 3 equals 1 over f prime of g prime of 3 equals 1. And then luckily they tell us f prime of 1 equals -4, so this is just going to equal -1/4, or C. 55 and 56 are something else you have never seen before. So one thing you're going to need before being able to do this, the derivative of arctan is going to equal 1 over 1 plus x squared. So that's just something you have to memorize. So looking at this, since ours is arctan of 2x, derivative of arctan 2x is just going to be 1 over 1 plus, replace the x with 2x squared, and then because of chain rule we have to multiply it by the derivative of 2x, which is 2. And then I want you to simplify a little bit, so 2 over 1 plus 2x squared is 4x squared. So the answer here is D. You would just have to memorize that arctan derivative. And the same thing goes with arcsine. So before you do this one, you need to know the derivative of arcsine of x is going to equal 1 over the square root of 1 minus x squared. So likely in our case, when we're looking at this, we had arcsine of e to the x. So this would equal 1 over square root of 1 minus e to the x squared times the derivative of the inside, which is just e to the x. So in our case, it's going to be e to the x over square root of 1 minus, and then e to the x squared is just e to the 2x. So our answer here would be C. And I just suggest you memorize those arctan, arcsine, arccos right before the test. Okay, 57, we have an implicit, but this time we need a second derivative. So we're going to do it the same way. We're just going to have to do it twice. So here we're going to end up with 2x minus 2y dy dx equals 0. And we still want dy dx by itself, so I'm going to have negative 2y dy dx equals negative 2x. Divide, so dy dx is negative 2x over negative 2y, which just simplifies to x over y. But now I need to take the derivative of this again. So I'm going to need quotient rules. So my second derivative, low derivative of the top is 1, minus high d low is dy dx, all over the square of what's below, so y squared. But remember, you can't leave dy dx in your answer, so my second derivative is going to be y minus x times x over y squared, which simplifies to y minus x squared over y squared. But that still doesn't look like any of our answers, so we're going to have to make this have a common denominator on the top. So this is going to become y squared over y. So then I'm left with, I'm going to come up here, y squared minus x squared over y all over y squared. So we don't want a denominator and a denominator, meaning this is really going to equal y squared minus x squared over y times 1 over y squared, which just equals y squared minus x squared over y cubed, which makes the answer A. If you get to something like this and you don't know how to simplify it, plug in some points and see which one matches. Okay, 58, we're going to have to find a pattern because obviously we don't want to find the 19th derivative of something. So let's start. G of x we know is cosine of 3x. Then G prime would equal negative 3 sine of 3x. Second derivative is going to equal negative 9 cosine of 3x. Third derivative is going to be positive 27 sine of 3x. Then our fourth derivative is going to be, I don't know, but it's going to be 3 to the 4th power cosine of 3x. So basically, you see how it's back to normal cosine? It's just going to keep repeating itself. So here's the fourth derivative. The fifth derivative is going to be the same as this one. 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th. So it's going to be a positive sign. So we can automatically get rid of A. And then notice C doesn't even have this part, the 3 to the whatever. Notice the exponent matches what derivative it is. So it should be to the 19th power. So really we should have 3 to the 19th. Then we knew it had to be a positive sign 3x. So the only answer there is D because B is a negative. right, 59. We're going to do something else very similar to that one because obviously we're not going to find the 50th derivative. So we know f of x equals e to the 2x. First derivative, 2e to the 2x. Second derivative, 2 squared e to the 2x. Third derivative, 2 to the third e to the 2x. Fourth derivative, 2 to the fourth e to the 2x. So you can see the pattern here. This exponent is going to match whatever derivative it is, and then e to the 2x will come after it. So we can see that our answer should be B. If we're looking for the 50th derivative, it should match. And then 60, here we're looking for the third derivative. We're just going to actually do this one. So our first derivative should be 4x to the third minus 15x squared plus 20x minus 4. Second derivative, 12x squared minus 30x plus 20. Third derivative, 24x minus 30. So our answer is B.